Okay, I'm starting this video knowing my cat is over here and knowing she's going to say hi to you guys, but I don't know. Cats aren't too bad. So we're going to talk about another way to solve logarithmic equations. The first method of solving logarithmic equations actually works on everything, but we're going to do something very similar. So again, logarithmic equations are also one-to-one. So just like the first video, we can solve things. If I have a logarithm of one thing equal to the logarithm of something else, then the insides have to be equal to each other because they're one-to-one functions, okay? So that's essentially how we're going to solve these problems. Example 6. Solve the following. Part A is the natural log of 10 minus 3x is equal to the natural log of negative 4x. And be very careful. Hopefully your gut reaction, hopefully your gut kind of clenches. You see, natural log of a negative. Jason, we can't take the natural log of a negative number right now. But don't worry, right? If x is negative, right? If x were negative 2, this is still the natural log of a positive number. All right, so don't freak out. Not yet anyway. So when are these natural logs equal to each other? Well, when their insides are equal to each other, just like we started this section out. Okay. So let's add 4x to both sides. That'll give us 10 plus 1x now. And subtract both sides by 10. We'll get x is negative 10. And let's check our answer. Make sure we're right. Make sure we're not lying. Make sure we're in the domain. We could find the domains, right, by setting each of these insides greater than 0 if we wanted to know the domains. Anyway, let's check our answer. Is the natural log of 10 minus 3 times negative 10, is that equal to the natural log of negative 4 times negative 10, which is positive 40? Well, the left-hand side is going to be the natural log of, this becomes negative 3 times negative 10 is plus 30. Is the natural log of 40? Well, I don't know what the natural log of 40 is, but I can sure as heck tell you that whatever the natural log of 40 is, it's the natural log of 40. Okay, so we're good. Right? And we are inside the domain. We don't have natural log of a negative number, only natural logs of positives here. So, excellent. We did it. Part B. Log of x plus 3 minus the common log of x is equal to the common log of, I think I wrote down a 74. We'll see. And so you might look at this and say, well, that sucks. Time to go home. We don't have the logarithm of something equal to the logarithm of something else. There's two logarithms over here. If we add a log equal a log, we could solve it. If only there was some way of combining these two logarithms. What if I told you there is? There's a minus sign, by the way. Subtraction of logarithms is the quotient of the insides. The left-hand side becomes the logarithm of this first thing divided by the second thing. Hey, look at that. Properties of logarithms coming in clutch for us right here. So now, the common log of something equals the common log of something else. Their insides must be the same by the one-to-one property. And now we solve this equation. This is a rational equation. To solve this equation, we multiply both sides by the LCD. The lowest common denominator is x. Multiply that side by x, multiply that side by x. On the left, they're going to cancel. We're just left with x plus 3. On the right, we're left with 74x. We have to solve this equation. So, let's get all the x's on one side. Let's subtract an x. 3 is going to be 73x divided by 73. X is 3 divided by 73. It's a weird answer, but maybe it's the right answer. If you're unsure, you could check it. This one really helps if you check it with a calculator. So let's check our answer with a calculator. So the left-hand side is the common log of x, which is 3 over 73, plus 3, minus the common log of x, which is 3 over 73. That's equal to 1.869 something. Is that equal to the right-hand side? The right-hand side was the common log of 74. And whoa, those are the same answers. So they are indeed equal. And we know that we have the right answer. It's a weird answer, but it's the right one. And again, we're going to give an exact answer. Don't give a decimal approximation here. Exact answers unless I ask otherwise. All right, we do part C, maybe look a little weirder. I'll say log base 9 of 2 plus log base 9 of n squared minus 7n equals log base 9 of negative 45 plus n squared. Lots of weird stuff. If we have log equals log, then we set the insides to equal. Left-hand side's 2 logarithms though. Well, we want to make those 2 logarithms into 1. Addition of logarithms is multiplication of the inside. So this is log base 9 of the first guy, 2, times the second guy, n squared minus 7n. And that equals log base 9 of the right-hand side. 2 logarithms equal each other if and only if their insides are equal to each other. So the left-hand side is 2 times n squared minus 7n. The right-hand side is negative 45 plus n squared. We got to solve this equation. And what kind of equation is it? It's a quadratic equation. So you're going to have to use your quadratic formula, your complete the square, your factoring, break out everything. Let's get everything on the same side. Linear equations, you get the x's by itself. Quadratic equations, you get everything over to the same side. So if we distribute this, we get 2n squared minus 14n. We need to add the 45 over, and we need to subtract the n squared over. Now there's nothing left on the right. Combine like terms, 2n squared minus 1n squared is a positive 1n squared. And we have the minus 14n and the plus 45. We need something that multiplies to 45, that adds to negative 14. Negative 9 and negative 5 will work. And minus 9 and minus 5 quadratic formula would also work. We're going to get the n is equal to 9 and 5, which is great because I'm out of paper. And we could check our answers. So let's check our answers here. Because, well, I don't want to spoil it for you. But you have to check your answers here. Because sometimes, I don't want to spoil it for you. Have to check these ones. You absolutely have to. Let's check 9 and 5. So if we plug in 9, this is awkward. We plug in 9, what are we going to get? We plug in 9, we're going to say, okay, log base 2 of 9, log base 9 of 2, plus log base 9 of n squared, so that becomes 9 squared, minus 7n, that's become minus 7 times 9, is that equal to log base 9 of 45 plus n squared? Let me check our answer. Left-hand side, right? That's log base 9 of 2. This is log base 9 of 81 minus 63 is 18. Is that equal to log base 9 of 81 plus 45? That's 126, I believe. Wait. Hold on. This one is supposed to... This one's supposed to work. Did I make a mistake? Yeah, negative 45. Great. All right. So negative 45 plus 81, that becomes a positive 36. Oh, and we can multiply the insides to get log base 9 of 2 times 18 is 36. Yeah, that's equal to log base 9 of 36. Great. So this one checks out. The other one, I've kind of spoiled it a little bit. N equals 5. Does that one check out? Got log base 9 of 2 plus log base 9 of n squared, so that's 5 squared, minus 7 times n, which is 5. Is that equal to log base 9 of negative 45 plus 5 squared? Well, let's keep simplifying. Log base 2 of 2 plus log base 9 of, this becomes 25 minus 35. 25 minus 35 is negative 10. Oh no. Let's stop right there. This is not a real number. Negative 10 is not in the domain of a logarithm. Ugh. All right. This is not it. So, not an answer. So we only have one good answer. N is only equal to 9. So you really do need to check your answers right here. Make sure that when we solve this equation, we're not getting answers outside of the domain. Another way of saying this is n equals 5 is not in the domain of the original problem. We could find the domain of the original problem, but it takes a bit of work. So there's an added benefit of checking your answers. 1, make sure your answers are correct. And 2, you have to. All right. All right, let's do the last example of today. Oh, last example of this video. We got one in the next video. Example 7. Solve and graph both sides. And again, just like I mentioned before, this is just good to see it, have a conceptual reflection of what's going on. I'm not going to ask you to use a graphing calculator or Desmos on your quiz or exam. All right, so we got 3 divided by the log base 2 of 10 minus the common log of x minus 9 is equal to the common log of 44. This problem is rough. Okay, there's a couple of things. 1, we got a logarithm in the denominator. I don't like that. 2, this is log base 2 and this is the common log. Ugh. If we get a single logarithm is equal to another single logarithm, we set their insides equal to each other and we go home happy. But we can't combine these logarithms if they have different bases. Luckily for us, we have a way to get a different base. Let's use a change of base formula on this one. Okay, we need the change of base formula. Otherwise, we can't possibly combine them. All right. So, log base 2 of 10, let's use the change of base formula. What base are we going to change it to? Let's change it to match, log base 10. All right. So this is going to be log base 10 of the inside divided by log base 10 of the base. Oh, this is really nice. The common log of 10 is just 1. The common log of 2, that's irrational. It goes on forever. So our denominator is equal to 1 divided by log of 2. A little bit of magic's going to happen right here. So we have 3. Our equation is 3 divided by our denominator, and our denominator is 1 over log of 2. No good news just yet, but it will become good news. Minus the common log of this other thing equals the common log of 44. It'll get better, I promise. Remember, 3 divided by this fraction is the same as 3 times the reciprocal. So this becomes just 3 times the log of 2, which is a lot better. Again, the rest is staying the same. Again, we need to still combine these logarithms. It's a good thing we did a lot of practice in the previous section last week on combining logarithms, properties of logarithms. We can't combine these with the quotient rule because there's a coefficient. So we move this coefficient up top. It's going to become the log of 2 cubed. The 3 goes into the exponent, 2 cubed, and 2 cubed is 8. Again, everything else is just staying the same. So we have subtraction of logarithms. That'll be the division of their insides. 8 divided by x minus 9 is equal to the log of 44. And finally, we've got a logarithm is equal to another logarithm. So we set their insides equal. 8 over x minus 9 is equal to 44. Another rational equation, we multiply by the LCD. Multiply both sides by x minus 9. So the left-hand side, they cancel. We're just left with 8. The right-hand side, we distribute, and we get 44x minus 9 times 44. That's 396. Add 396 to both sides. And we're going to get 44x is equal to, whoa, that looks weird. 44x is equal to 396 plus 8, which should be 404. And divide both sides by 440. Or sorry, by 44. And you're going to get 404 over 44. I don't think that divides evenly. Yeah, it does not. We can reduce it, right? They're both divisible by 4. We're going to get 101 divided by 11, which has the same kind of look, right? And I don't think this is going to reduce anymore. Okay. And there we go. This is our potential answer. Let's check our answer. Let's make sure that this is in the domain. Okay, so we check our answer. And we say, is 3 divided by log base 2 of 10 minus the common log of 101 over 11 minus 9, is that equal to the common log of 44? Let's use a calculator for this one. Okay. So we go off to the side. We say, okay, we've got 3 divided by log base 2 of 10. I think you can type in log base 2 of 10 on this. Minus the common log of 101 divided by 11 minus 9. That's equal to 1.64. Is that equal to log of 44? It is. Great. And remember this problem, remember what this problem originally asked us to do. It said, check your answer by graphing both sides. So let's graph both sides of our equation. The left-hand side, it was 3 divided by log base 2 of 10. That's not 10. 3 divided by log base 2 of 10. Minus the common log of n minus 9. Was it n? N was a different problem. It's x. That was the left-hand side here. The right-hand side was the common log of 44. Question is, are these equal to each other? And I must have made an error in my graph somewhere. It's not graphing this. This is bizarre. What did I do? Let's try it over. Y is equal to 3. It's graphing. Divided by log base 2 of 10. Still graphing. Minus the common log of x minus 9. And it's not graphing it anymore. Minus log base 10, x minus 9. Oh, we were just really zoomed in. It wasn't there. So we got the x coordinate is, oh yeah, because the log of x minus 9, right? That's the logarithm that got shifted right 9 units. So our x value is 9.182. Is that what we had? 9.182 for our x value? Well, we have 101 divided by 11. That is 9.182. Yeah, great. Cool. And graphically, we can see it here. Graphically, we can see it here, yeah. We cannot see it here when we're super zoomed in. Great. All right, and that's this video, which was also long.